let's try to work with this. And today we are talking about web application architecture, and mostly with a client-server apps and REST API. So let's begin. My name is Jyväskylä. I'm a developer at a company called SC5, and we do mostly HTML5 stuff, and both here in Jyväskylä and also in Helsinki. And I'm from Espoo. And a little bit about me. I graduated 2 years ago from a school that is now called Aalto University, and I have been working doing internet stuff since something like 2008. And here's a picture of me trying to grow a mustache, and that didn't work at all. So, but a couple of practical things first. My train will leave at 7:16. I want to be on it, and if it's okay, we could just have no break, because I think these slides will take something like 1 hour, and after that we can have some discussion. But I like Jyväskylä, but I want to be on the train. So we are talking about web application architecture, and so it means stuff that lives on the web and is mostly built on using web technologies, but we'll also touch native apps and how this works for them. And I have quite broad definition for applications, mostly things that do something useful and are somehow dynamic. And if you think about it, so most of the things that you see on the internet today are kind of applications. And we'll focus mostly on the client-server model and talk about a little bit how to structure an application. But I think you have a lecture about that in 2 weeks, about how to structure an application. So I'm not going too deep into that. So we are talking about applications like Pinterest or Kept for storing your bookmarks, and stuff like Facebook, obviously. So almost every kind of applications. And before we start, I want to talk a little bit about the environment where these applications live today. So there are a couple of things that affect how we build applications, and these are, first of all, the fact that today there isn't any one device that people use to surf the internet, and these are 3 applications that work on the mobile, but they also have desktop versions. But the point is that when we start building an application, we often can't really know in advance what devices people will use to use those applications. So it would be good if the application would work on each of those different applications, different devices. So your users might have a tablet or a mobile phone or a really large display at home. And maybe today we can say that there are like 3 different device types, desktop, tablet, and mobile phone. But it's only getting worse and worse, because now you're having devices like Windows 8 tablets, which try to be both desktop and tablet devices at the same time. Or maybe like the new iPad, which is somewhere in between those full-size tablets and mobile phones. And then, of course, you have those Android phones, which are, some of them are as large as some tablets. And this is one challenge. It's, of course, a challenge for the design. So how to make the things look good on each device. And we have some tools like responsive design, which can help in that, to make the things look good on each device. But I would say that this is also a challenge for how to build those applications or the architecture behind them. And okay, to be honest, so when I started doing this web stuff in 2008, I would say that most of our clients, they never asked for mobile websites. And if they did ask for a mobile website, it was always an afterthought, something that came up when the project was almost done, and then someone thought that, oh, by the way, should we do something for the mobile also? And usually at that point there wasn't any money left or any time left, but it was okay because back then people thought that mobile users, they're like those busy guys on the street that only want to see the most important information, like when is the shop open or what's the phone number if I need to call those. Unfortunately, that's not true anymore. So today you are expected to deliver the same content on each device. So you can't have a really small mobile version that doesn't include the same content as a desktop version would. And if we look where people use their mobile devices, a lot of that usage is at home. So it might be on the bed or a toilet or generally that's just home. And actually, people might only have the mobile device and not a computer at all. Or maybe they're just too lazy to open a computer just to go to some website. So this isn't like the traditional mobile usage that you might think. So in a sense, there is no mobile user anymore. What that means is there isn't one mobile context or one design that would fit all mobile users. So that's one challenge. And next up, cloud computing. So what we mean by cloud computing is that you host your applications on a server farm somewhere, or you have more or less virtual server somewhere in the cloud. And that's sort of an opportunity because you could scale your application just by adding more servers to it, or maybe more databases. But it's also a challenge because your application needs to be built in a way that it can actually be scaled just by adding servers or databases. And okay, to be fair, most of the applications that we build, they could run fine on one server and one database. But I think it would be foolish not to think about scaling in the beginning because it's quite a lot harder to do after the fact that someday you have a million users and nothing's working. And third thing in the environment, the demand for great user experiences will just go up. And this is something we need to take into account, especially when building HTML5 applications, because they compete with mobile applications like native applications that people use from day to day, which have like very great user experiences, and people are used to those experiences, and sort of start to expect those experiences from also HTML5 apps. So if we want to make an HTML5 app, it should be as easy to use as a native app and work as fast and be as responsive. So I have one example, if this works. So, should I get sound? Anyway, this is just to display how smooth those applications can be, and that's becoming the expectation of users, that everything works as smooth. So, quick recap. This is the environment we are building applications today. So, lots of different devices, lots of different contexts where people use those devices, and also some opportunities from cloud computing and the demand for user experiences. So, let's get to business. I thought I could show you one way how not to build web applications, and then some more sane ones after that. So, first up, PHP soup. This is maybe something that if you're learning to program and happen to discover PHP, this is what you mostly end up with. And what I mean by PHP soup is having HTML with random PHP code in between, and maybe even some database queries there. And this is how many people have learned to build web applications, actually, because PHP is a very easy language to start with. You only need one server that supports PHP, and most servers do support PHP. So you only need to upload one PHP file to the server, and you got something dynamic already. So I wouldn't say that it's PHP's fault that it's easy to learn, but if no one tells you how to build applications with it, you might end up with some pretty horrible code like this, and this. You have single PHP files everywhere that handle both the dynamic content and also the layout and how it should look. And if you want to add more pages, you add more PHP files. And this looks handy, right? So there are some pros and cons, and well, it's actually possible to build something with this style, and I must admit that I built my first web application in 2006 in this style, and it's still in use today, and it solves a real problem every day. But the code is horrible, and I don't want to look at it, and I probably couldn't fix it if I wanted to, because I would most likely break something in the process. And also I can't let anyone else see it because it's such bad code. So any option to have updates to my web application would be do a complete rewrite, and that's not an option, really. So don't do this. This is how I feel when I look at my code, if you get what I mean. Yeah. So you don't want to do that. So maybe something more sane now. So let's get to web application frameworks. And what I mean by these are some backend frameworks. And these are frameworks that are designed to help you build an application for the web. So they mostly handle stuff that you would need in a web application, like talking to a database or handling requests. And there are quite many frameworks. Each language has multiple different ones to choose from. There are things like Zend, which is quite popular, and Ruby on Rails. So anyway, I think the only difficulty would be to know which one to choose. And what this picture tries to represent is that and web framework usually does that. It listens to requests and then gets some data from the database and passes that data to a view, and then responses with an HTML file back to the user. And all of this happens in the back end. And some of the features that these frameworks tend to have, first of them is this object relational mapping. That means that it creates a layer between the database and your code. So basically you can write code that handles objects like video, and the layer between your database then translates that code into SQL code. And what's cool about this is that you don't have to care about what database you use, because the layer knows how to translate everything to the database that you use. Another thing, routing. This decouples your addresses from the actual code that handles those requests, and you can have like dynamic routes which have variables in them, so that each request to an address called products/a number would then go to this catalog class and get by ID function. So I would say that this feature is found in almost every framework. And third up, templating, which basically means that you use HTML files which have some placeholders for the data that you fetch from the database, and then fill in those blanks here. So this code in Django, it would fetch a list of videos and produce HTML that has the name of the videos in a list. So I mentioned these three features because together they form something of a MVC framework. And this MVC is a widely used model for building applications, and there are some variations of it, but basically usually the controller listens to user input, then manipulates the data, and then passes that data back to the view layer, and that updates, and the user sees the result. So the advantages, if you compare this model to the PHP soup, is that you have decoupled different areas of the applications. You have a controller that only cares about handling the inputs and passing the input forward or getting the right data. You have a model which handles the data from the database and back to the database and knows about business rules. And then you have the view as a separate thing that knows how these things should look like. So it's a quite clear separation, and you could, in theory, you could switch one of these, like you could switch your database to another without touching the code in the controller or view. And this works pretty well, which is why it's quite widely used. And that means that there are some quite a lot of resources on how to build these applications like this. And I would say that I think it's safe to say that you could probably get a job doing applications like this if you just learn one framework really good. And some disadvantages. These frameworks, they all start from the idea that you have one request that comes from the browser, and then you figure out what to do with that request, and then pass some HTML back. So every time the backend gets a request, it has to decide what kind of request is this, what data do we need, and how the end result should look like. And then we get a HTML page sent back. So when a user wants to surf on a site, they would generate lots of requests that always go to the back end and come back. And if you're talking about an application, so this model doesn't always fit that idea that well. The user might want to see some feedback from their actions right away and not wait that the request goes to the server and comes back. And you could make the requests faster, optimize the backend so that each request only takes 1 second or something. but there's a limit to that, how far you can go with that. And okay, so we have things like Ajax, which is basically that you can load a part of a web page with an Ajax request and get that part from the server, and so update a page, update page content without reloading the page. So, for example, if you have a picture gallery, you could load the next picture with Ajax. Or maybe if you have a form, you can submit the form and get a response back without reloading the page. And this is quite basic stuff still. And this works pretty fine in a case where you just want to submit a form or load some more content. And this actually is very good for the user experience, because the Ajax request is usually it's a lot faster than reloading the whole page. But what that means on the server side is that the server at some point must decide if the request is an Ajax request and have a different response for that. And detecting this Ajax request is quite easy, but anyway, you start having different code for handling Ajax calls. This is how it would look in Django. Quite the same thing. So, at some point, even if you would use the same templates for Ajax and non-Ajax requests, you need to have some different code for each. So, let's pretend that we are back in 2010 and we want to build a separate mobile site. So let's add that to the mix. Now we have a third option. We might have some method of noticing when the request comes from a mobile device and have a different template for that, or the basic checking if it's Ajax or not. But what happens if the mobile device supports Ajax calls? Now we have 4 options. So you might have a mobile device which makes Ajax calls and have a different response for that. And anyway, you might see where this is going, is that when you add more devices to the mix, or more different view types, it's starting to become less easy to maintain. And for every different device, you must add some different code to the back end. And also on the front end, it's not that easy either. So you might have a page that loads like different content with multiple Ajax calls, and it becomes quite hard to maintain the page state. So you don't know, or you have to keep track when each Ajax call has completed and know what the user is seeing at that point or what they can do. So let's take our favorite tool, separation of concerns, and apply it once more. So, what if the backend didn't care who wants to see the data or who makes the request? What if the front end could decide how to display the data or how to manage user input? And what if backend would only return the raw data to the front end? So now we get to the REST API architecture. And I'm sorry about the picture. It's a bit messy, but what it tries to say is that we take the view from backend and move it to the front end. And we have a complete application in the front end with its own database for storage. And this front-end application is actually the one that makes these views and outputs HTML. And the backend only talks something like JSON to the front end. And in between, we have a REST API. This is the same picture, but drawn by our boss. It might be a bit more clear. So anyway, what I want you to learn from this picture is that we take the front end and the back end and separate those two, so that they each have one mission, and they only talk to each other through this JSON. So what that means is that in the front end, we have either a single page app, which can be built with HTML5, or we might have a native app or something in between. And the single page app maintains its own state. So even if you take it offline, it knows what content you have and what you can do with the content, and it only syncs the content to the back end when it needs to. And so every change to the state is also handled by the front end. So if you, let's say you navigate to another page in the front end, so the front end can do that on itself, and the back end doesn't need to know about that. And the back end would just care about data storage. So in a sense, we draw a line between those, and there's the API in between. And if we are talking about REST architecture, there are some constraints that help define the architecture, and we might go through these. So, as we saw, it's a server-client model. So, once again, the front end doesn't need to know what the back end does, and the back end doesn't need to know what the front end does with the data. And you could also change either one if the API stays the same, or have multiple different front-end applications that use the same API. And what's important is that they both can be developed independently. So you can make changes to the back-end code as long as the REST API in between stays the same. So the backend is stateless. and each request to the backend is handled independently of the previous ones. And cacheable, this is good for minimizing the traffic between the front end and the back end. So the back end should always define if a response can be cached or not. And usually it's done with these HTTP headers like cache control or e-tags. So you can make something called conditional get, which it only gets a response if there's some new content or the content has changed. A layered system, we'll get back to this in a short while, but basically you can have multiple layers in the back end and the front end doesn't know about that. That's the point. And okay, so there's a uniform interface, and this is a bit harder to explain, but basically the interface is defined in a way that so that each resource in the backend has some kind of identification, and you manipulate those. But this is easier to explain when I get to the pictures and stuff. And okay, these last two things, they mean that a REST API should be discoverable without any knowledge about the API. So let's say you build a robot and point it to the API. It should be able to follow some hypertext links and find out how the API works. But this is not that important. So, pictures. This is the basic setup, that you have a server and a client, and they talk to each other through the API. And this is the layered system. You might add a cache server in between. As long as the client gets the same data, it doesn't need to know what's on the left side. And you could really scale it up with a load balancer, multiple cache servers, and multiple application servers, as long as the API stays the same. So you might have magical unicorns on the left side, as long as they output the data in a format that the client expects. But you might not find unicorns. So, some advantages. I would say that when you are building an application, dividing the task into two different parts helps you, because you can really focus on one part and leave the, let's say, leave the backend to some other guy that does the backend. And it's really easy to write tests for the backend. So when you build an application with an API, you might have a set of tests that test each API endpoint, so that you can be sure that the API always returns the correct data, or you might test that the update to the API works as it's planned. And when you build an front end on top of that, it's much less scary because you know that the API works already. And of course there's the scalability. But there's also this disadvantage that you could have multiple different clients that all use the same API. And I would argue that it's easier to build those applications when you have the API. Because in a sense, you have half of the work already done. So, if one day you decide that, okay, we have this cool web service, but what we would need is an iPhone app, it's a lot more easier to build that iPhone app if you have the API, and it's also a lot more difficult to start building the API in that point when you notice that, I need an application. It's near impossible in that point. Or not impossible, but that adds like 6 months to the build process. Also, if you have a really good API, you might get some people that build applications for your API. And this is, for example, how Twitter got started back in the day. They had many developers building applications for their API, and it helps Twitter to become successful. And many other companies have used this. So, next, a quick introduction on how to build an API and what an API should have. First of all, as said, all resources should be identifiable with an URI. And those URIs have a clear structure. So you have a list of resources or one resource in a list. Or maybe a third option is to have relations of two different resources. Example, if we have API endpoint videos, you might get a list of videos, but usually not all the information about every video, but the ID and maybe some more information. And an address with a noun and an ID gets you the one resource and all of its information. And when designing an API, you should keep your addresses quite simple and only use those nouns. And overall, this helps you keep the API like simple and predictable, so you don't have any crazy like update author endpoints. And what this does also is that some addresses like these, they don't tend to change over time, which is a bonus. there are some cases when you can use those query parameters, mostly when you're limiting the amount of data you want back, or when you're searching something. So you don't have any other way of, or any useful other way of saying that I want to search for cats than this. So that's how you access those resources, but if we want to manipulate the resources, we use the HTTP methods we have. And usually we use these four methods. There are some more HTTP methods, but these are the four common ones. And so post is used to create get to read, and put request would update and delete, well, deletes. So example. These two work as previously. If we want to add a resource, we post to the list of resources. This creates a new resource. If we want to update a resource, we must define its say its ID, and in the request payload we should have the updated information. Or in some cases we must have all of the information, but that depends on the API. And well, deletes. Okay, so these are the cases that are not that well defined. For example, you might send a put request to the list of videos, but what that would maybe do is update all the videos, and well, that's not very useful usually. So in my opinion, it's okay to ignore these, or maybe return some error message. And of course, APIs usually have some kind of authentication, so you can't read other people's data or delete some data that you don't own. And you might start with basic HTTP authentication. It's totally fine. And quite many APIs use this OAuth and some API tokens. OAuth, that's a system where the user authenticates with the service provider, and your application gets an API token back, and then you can use that token to request data from the API. But at no point do you have the user's password or username. So that's quite secure. And some of the APIs support that you can request access, maybe only read access or both read and write accesses. And this is actually good if you're maybe writing a Twitter client that only needs to read data. Users might be more willing to use your application if they know that it can't post to the Twitter Twitter account. But anyway, this is something that you probably shouldn't build yourself and use a ready-made OAuth library if that's possible. So now we know how to access an API and how to manipulate it, but what should an API return? And the most easy answer is JSON. I think most of the APIs today use JSON, and it's a safe choice. Most programming languages support JSON out of the box, and it's quite easy to debug, and it's readable, and in all ways more fun than XML. I think if ever you can avoid using XML, you should avoid using it. And you should probably use some of those basic status codes when you respond to a client. These make the developer's life a lot easier when you respond with a, for example, 400 bad request, so the developer knows that something is wrong in the request that they're sending. But these are not that clearly defined. So, for example, if you post a new object to the API, it might respond with either 200 or 201. So I don't think there's a correct way of doing this. Both are fine. So the inventor of REST API is this professor, and well, he's pretty mad at people using the term REST API when we are talking about just a random API that just has those features that we discussed to this point. And well, a real REST API should use hypertext and be machine discoverable. And the resources should always define what kind of requests you can make against those. But anyway, I don't think this is something that you should have to do when you're designing an API or building an API. So what people these days mean by REST API is just that you have an API which identifies those resources with your eyes, and you can manipulate the resources with get, post, and put, and delete. And if the API gives results back in some machine-readable way, like JSON, so you have already covered like most of the bases, and you get all the benefits of using an API already at this point. So the additional benefit of being discoverable by magic robots, I don't know if that's worth the trouble, usually. So, it's not all rosy. Usually APIs are very easy to use, but building those is a bit harder because of a couple of things. But the balance is like people who might use your API want it to be very easy, or they might just go elsewhere. And you have the responsibility of making the API easy to use, and that's usually a more work, lots more work in your part. API changes. We said that the API is like the magic thing in between those two sides that never changes, but sometimes it changes, and what you do then is hard. One option is to use API versioning and include the API version in the address always. So when you get a request to API version 1, you know how to handle that request. And well, this might help for a while, but of course you can't really have like 100 different versions of the API, because once again the code behind the API starts to grow and become unmaintainable. So at some point you should probably just say that from this day forward the API will now look like this, and you should update your applications. And semantics. So it's not always easy to make a name for things, and especially if we are talking about relations, that's usually harder. So the example is, well, it's made up, but you might see that there's lots of different ways of solving a problem, but most of them might not be right. In this case, if we are blocking a user, I might go with this fourth one and create a relation, but I don't know if that's the best answer. And in real life, you can't always decouple the back end and the front end. Usually they end up sharing some stuff between those. Or you might have some things that the front end must know beforehand. And, well, usually that's okay if it's just a couple of things that are common. And when building an API, you should write good documentation, because if you ever want other people to use your API, you should be able to just hand them the documentation, and they should be able to understand the documentation and start writing applications. And that's quite a hard thing to do. But overall, I would still say that using an API is beneficial, and you should do it. Even if you don't do it like 100% of the way, it's gonna still give you some benefits, just because of the decoupling and making your code more readable. So a little bit about the front end. So here's the picture again. We talked about this backend and the REST API. And in the front end, we have the single-page apps. And what single-page app means is, well, it's built using web technologies like HTML and CSS and JavaScript. Uses client-side templating like mustache or underscore. Has some way of storing data locally in the browser. And does some kind of client-side logic. What that means is, well, for example, if you click a link in the single-page app, you get the results immediately. And, or for example, if you submit a form in a single-page app, it gives you the feedback right away, but then sends the data in the back end after that. But you anyway get the good user experience by getting the response fast. And what else? So a little bit about how to structure an application. There's going to be lots of code in your front end if you're building a single-page app. So you should use some way of managing that code. And one way is to use an MVC library in the front end, like backbone.js. So Backbone has a simple model view controller structure, but what's cool about it is that it supports REST APIs out of the box. So if you use Backbone.js, it knows how to fetch data from your API without you needing to write some custom Ajax code to fetch the data. And when you have lots of code dependencies come a problem, and require.js is one tool that can help maintaining those files and loading them in order. But it's not the easiest tool to use, but I would say it's, unfortunately it's the best tool we have at this point before JavaScript gets some module loading system. And I would say that use CoffeeScript if possible. It's a language that compiles into JavaScript, but it has a much nicer syntax, and it helps you avoid some of the gotchas that JavaScript has. So for every 2 lines of CoffeeScript, you get 3 lines of JavaScript back, usually. But this is the topic of Mikael when he comes in 8th of November here. And if you want to get started with REST APIs, I'd say that the best option is to pick a tool that you know how to use, and use that to write an API. Most languages have some libraries that help you build an API. And of course, you also learn a lot by using a public API. So you learn how they usually work. And one good place to find those is this programmableweb.com. It has a directory of 7,000 APIs, and you can filter those with some keywords. Also check out this apig.com. There's some good videos and books about building an API. So that's what I have about APIs at this point. So thank you.